here to talk about security, coding, and the focus on Java. I talked to Paul, geez, I don't know, a year ago, and I told him, hey, you know, eventually I'll do a talk on Java security-related stuff. Initially I had a plan to talk about like robots and lasers and all sorts of cool stuff that we're working on here, but that's all in Python, so he said I can't do it. I'm kidding.
You have lasers and robots here?
Yeah, quick, you know, talked a little bit about what I do, I suppose, but Cristian Pimentel. I've worked in a couple different industries. A few years ago was in, I guess what I'd call healthcare, kind of peripheral healthcare, and am now back in that general space, so med tech, manufacturing, kind of an interesting space here at ResMed. I'm the director of security engineering here. I basically joined this organization 2.5 years ago with the, kind of given the mantle of software development security. I had to create a program here. So some of the stuff that I talk about today with some ResMed people that I see sitting here and over here, probably stuff I kind of keep reinforcing. Maybe they're tired. Actually, I guess not too tired because they're here. But I'm kind of talking about this day in and day out. Yeah, I've worked in government IT, financial services before here. And it's kind of funny, the common thing you hear is the financial sector has it all figured out. Or at least they say, hey, look to the financial sector for kind of how to protect your, your ecosystem or your platform or what have you. It's kind of true. You know, they're definitely ahead of quite a few other industries, but you still see a lot of quote unquote ownage happening in that space. There was like a Swift banking attack maybe a year or 2 years ago. Geez, 3 years ago now I think about it. Yeah, yeah, to do Comic-Con coming up soon, so looking forward to that. Assuming that I don't get told that I have to work on Thursday. I'm crossing my fingers. Yeah, what else should I say about this before we move on? That's about it. I mean, the only thing that I will say is yeah, a big chunk of my career was actually doing software engineering, to your point. The reason I kind of hesitated at answering, because on my team, I have really only one other guy who has that background. We focus more on just like managing the programs now, because we're a very small team. Like my team consists of 3 people, including myself, and an intern who just hired, which is awesome. And I've seen quite a bit. Maybe not as much as everybody here, but I definitely, every time I learn something new in the security space, I think back to a lot of the really crappy mistakes I made, and I think, wow, I hope my code from 10 years ago is still not sitting in production. A funny story related to that is, before I just jump into this, is, geez, back in like 2000 or so, I was working for a place that I won't say, and I was developing this really, basically wrapping up school and developed this really crappy, now that I think about it, database-backed system. And it was like shared, and you can, if you're on the local network, everyone can connect and so on and so forth. Thinking about it now, like all the decisions I made, awful. Security prone to know it. 6 years later, I'm at lunch and I run into one of the guys who I used to work with. And he goes, oh man, we still use that thing. Like, yeah, it's great. I'm thinking, oh my God, it's kind of sad. So, something to think about, secure coding, we're putting stuff out there, we're building functionality, tools, platforms, selling things, whatever, internally maybe. Maybe we work as the internal IT function. Right, we're putting things out there that are going to be used. And what secure development really is just developing that software with kind of the added, sometimes unfortunately bolted on afterthought, but hopefully integrated thought of, let's protect it from vulnerabilities. And vulnerabilities can mean anything, by the way. You always hear like the big sexy stuff is like, oh man, this huge vulnerability was used to take advantage of so-and-so server and 100 million accounts were breached, or money was transferred from bank A to bank B. But vulnerabilities can be any sort of weakness that your system has, right? And generally, like the security 101 thing is you're protecting confidentiality, integrity, availability. So when it comes to secure development and coding, it really is kind of a broad swath of things you're trying to protect against, those weaknesses. So it's not just these kind of big, hey, someone's going to steal accounts or someone's going to steal money. It really is like, oh man, my service, someone can't reach my service, right? Denial of service sort of a issue. Authorization, authentication issues, those are the kind of the common things you hear about. But then on the denial of service front, there's also things like resource starvation. You don't always really think about like, oh wow, what sort of payload can they send that causes CPU use on my web app server to spike up and not, it's not available to any other request coming through. Those are the type of things that are weaknesses, right? Those are security weaknesses, but they don't really get generally they don't get kind of the news headlines. So, what are we protecting against? Tons of things. Again, if you're kind of going by the OWASP model, which is great, I mean, it's very good. The top 10 just was reassessed last year. It's things like cross-site scripting, SQL injection, and secure crypto, so on and so forth, right? But tons of things, as I mentioned. It's not just those. And secure coding, it's kind of a mindset that needs to my earlier point, needs just to be integrated from the get-go, right? So there are big sections of things to consider as you're designing, as you're implementing, as you're testing. And we're not going to cover all of those things tonight. I don't expect you to even pick up a few books or watch a few videos and like understand every single aspect of it, or even consider it as you're designing, the next system that you're working on, or go back to work. But if there's one thing that you should remember leaving here today, it's input validation. First thing I'll say, if anyone has better Photoshop skills, talk to me afterwards, because I know it's bad. But input validation, you look at the OWASP top 10, you look at a whole bunch of issues that come up, to a certain extent, even the serialization issue, or issues that kind of plague Java. A lot of it really does have to do with input. So do you trust your input? Why do you trust your input? Are you validating? Are you sanitizing, right? If you're familiar with kind of the Pareto principle, 80% of your causes, or 80% of your effects are caused by 20%. Basically, input validation is that big chunk of mitigation that you kind of make sure is there, and you'll probably cover the biggest chunk of things that you tend to see. So, if you leave early, pizza's done. We're at the halfway point, you think, geez, I know everything this guy's talking about, or I'm not interested. Just remember input validation. Even if you're walking out, head down, I have no idea what he talked about, but for some reason I want to validate input. Just keep that in mind. So, why spend the time? Kind of mentioned a little bit, right? Got to protect from weaknesses. But I'm just kind of curious, show of hands, how many people right now, place you work or whatever you're doing, have a, let's not even say formal security program, but you just know a resource that you can talk to about security issues at your org? It's a pretty good, 30%, maybe 40%, which is way higher than if I asked that question a year ago, and astronomically higher if you asked it 4 years ago, right? It's kind of interesting that even, speaking of the intern that is working with us right now, kind of interesting to see that it's becoming not just such a hot topic in the news, but even curriculum in universities are beginning to finally integrate much more deeply into a computer science program, computer engineering program, so on and so forth. We didn't used to see that. 18, 19 years ago when I was wrapping up, 18 years ago when I was starting and then wrapping up, maybe 1 or 2 classes. And I was a math computer science guy, so I got exposure more to cryptography and that sort of thing, but just general secure coding, it needs to get covered. And then the why, I'm going to just hammer this home every time I talk to anybody. And again, the HI team knows this. Health informatics team here at ResMed, sorry, I'm using acronyms that probably don't make sense to people. But yeah, if you bolt it on, if you don't think about it after, if you're only thinking about it after the fact, it's Russian roulette with your project schedule, hands down. Okay? And you're probably not protecting it very well. That's the reality. And in fact, it's Russian roulette, and you have 5 bullets, right, with 6 trainers. So hands down, you're going to impact. And you can substitute security with anything, right? Testing, whether it's unit testing, integration testing, user experience concerns, right? If you're bolting that stuff on at the very end, you are just blasting away your project schedule. You're probably blasting away functionality. Just don't do it. The other reason why, I kind of look at it like you have a whole bunch of teams, a whole bunch of organizations, and you're not really going to protect yourself against every single potential vulnerability that your system has, every single attacker that's out there, because there's new vulnerabilities that come out every single day, right? It's so. If you think about like homes and burglaries or cars and whatnot, they tend to be, opportunity, right? They tend to be crimes of opportunity oftentimes. A person's casing a neighborhood and a window's open. You have a whole neighborhood of hundreds of homes, but the one, you get home and it's yours. And what happened? No smash and grab. I left the window open or the door unlocked. One of my coworkers was just telling me a story about this happening to them. I mean, it's the same thing in what we do. You're kind of this big pack, right? Wolves out there, I guess. Not everyone who's, quote unquote attacking is just necessarily bad. But wolves come in. You don't want to be the person in the very back. You kind of want to be that guy. Semi-safe. Again, you're not maybe 100% safe, but at least you're ahead of all those other ones that are a little closer. You don't want to be this guy, right? So, and if you're familiar with Cheers and Cliff Clavin's theory about the brain cells in beer, it's kind of the same thing. Totally dating myself. I think only Paul is understanding that reference, but same sort of thing. It's like, why do we drink beer? It's because we're killing off the weak brain cells, so only the strong ones can survive. Yeah. Anyway, main point is you try to do as good as you can do, as well as you can actually code with the resources you're given, knowing that you're probably ahead of the pack, even just by doing a few, taking into consideration a few best practices. So, some examples, and we were just talking about serialization issues. But last year, 2017, the Equifax breach was caused by basically vulnerabilities in Struts framework. And I'm going to bring up a little article here. Hopefully I can get it moved over. So Oracle patches Apache Struts. And sure, you can maybe say, oh God, who's using Struts? But no, it's still being used, of course. And that's cool if your project's using Struts. I don't care either way. I just care that you're patching stuff. And ultimately, it resulted in remote code execution vulnerability, right? And unauthenticated, if somebody is running certain versions of Apache Struts, you craft a certain request, boom, you could run whatever code you want on that machine. The other thing that's kind of interesting related to the all these, and by the way, these are all in very similar class, right? It's those serialization concerns tied to the same sort of thing. Plantbase had a very interesting one that was known for quite a while. In fact, let me bring this guy up as well, if I can. And this is just another injection issue where, not a serialization issue necessarily, but Plantbase had a vulnerability where if unauthenticated, you send a specially crafted request, and you can run code on the server that's basically hosting Plantbase's incorporating app. And it's kind of interesting to see because it's literally, hey, I want to hit so-and-so server with this path and these query params. Kind of gnarly query params, but nonetheless, what ends up happening is it gets evaluated by the expression language, part engine used by Plantbases, and you can run commands in there. And I'll kind of show a demo in here in a second of how simple it is. But the main thing I'm trying to point out is that you sit back and you think, oh no, I'm good. You know, we sit through this. You know, we sat through. We made sure that our design's as secure as possible. You also got to kind of consider the stuff that your code that you're not writing, but is incorporated into your project. And we'll kind of touch on that a little bit. The so what is so what? Why do I care? I'm not Equifax, or so what? I'm not using Primefaces. I did want to kind of just show very briefly. This is a bit kind of contrived example, but very briefly why you should care and how easy it is to exploit these things. So give me 1 second here. Let me put this down. So what I did in preparation is just set up a couple of VMs. Move this guy out of the way. Okay, so on this machine, I'm just, older Tomcat variant with an older version of Struts, just to show you how simple these get executed. These exploits get executed. And I have this machine, it's an Ubuntu box, right? A tool that's used, a lot of people give it flack because it's like, oh, ankle biters use a tool. It's really just a testing framework. Kali Linux gives you a whole bunch of security related tools. One of the things that I'll kind of show here is the progression of vulnerability discovered to it being actually used and identified in the wild is kind of interesting. It takes this very quick escalation as soon as an exploit is released. So you'll read about theoretical vulnerabilities. It's like, oh, okay, maybe if you crafted it in such a way, but it's very difficult to execute. Eventually someone takes the time to execute this. And when someone takes the time to execute it, they end up oftentimes revealing, they try to keep it on their list often, but they end up revealing enough information to give, whether it's bad guys, whether it's researchers, whether it's whatever, enough information to say, hey, here's an actual exploit that you can use in the wild. And the second that those exploits hit the wild, you'll see the attempts skyrocket. Like, it's insane. Our security operations team, we have firewalls, we have web application firewalls that are just kind of trying to protect us as much as possible, do a pretty good job. But as soon as a new exploit is released, we know immediately, because we just see attempts spike up 2,000, 3,000, 4,000% in a given day. And so my main point here is that there's a tool called Metasploit. This will take 5 minutes. And it makes it really simple. When these exploits are released, and when you hear the term like script kiddie, I guess this is kind of what they're referring to. But these tools are actually pretty simple to use. Have a decent user experience, considering it's something that you can go and grab for free. So in the Struts example, kind of wanted to show you that I have a full database here. Let me make this a little bigger. Of various exploits, and I'm just searching for Struts. So there are a host of different, and by the way, way more vulnerabilities for Struts than this. These are just actual exploits that eventually people put together and put out there. So this guy is kind of the one that hit Equifax, and assume that I'm out there searching the net. As I say, okay, cool. There's a new exploit that I'm going to use. This is how simple it is to actually go ahead and take advantage of it. I say, yeah, I'm going to use this exploit. I don't even have to know anything about coding. Someone else did all the work for me, right? It's like, okay, I'm going to set the remote host to, and then I got to go find my other machine. I think it's 192, 168. We'll double check in a second. Let's say it's 44.135, I believe. I'll double check that. And all I'm doing is filling in the details I need to actually hit the machine. The interesting thing is, back to my point of kind of 144.130, like immediate increase in traffic once these exploits are released, it's also kind of interesting that you can scour the internet with search engines that are used for this purpose, like Shodan.io or Census is kind of a newer one. If you're familiar with these, I'll show you in a second. If not, I only saw maybe like 2 people shake their head. If you're familiar with these tools, you can basically say, okay, you know what, I'm looking for a website that uses prime faces. And it'll give you a crazy list of things that you can target, right? If you don't want to go out there and kind of get caught by scanning yourself. So I'm just going to tweak this because I'm using a slightly different URL. So 2, 3 dots, 1, 2. So bear with me here. So I'm just using like the demo Struts to showcase you know, web app war that you can download from wherever. And then I say, okay, I want to hit that machine and then have them connect back to me so I can issue actual, you know, more requests. So to connect back to me, let me double check what my address is, so 44.134. I guess I should have guessed that. All right. And I think I have everything I need. So all I have to do as a person who doesn't, you know, assuming I don't know anything, say, okay, well that's not the target URI, I'm slightly different, right? I've already kind of cased the site I'm trying to hit. I said, okay, well the remote host I'm trying to hit, I just set that value, okay? And then, okay, I want to connect back to me, so the local host, which is somewhere in here, I'm sure. Local host is this guy. Then the last thing I really have to tell it is, well, what do you want it to do? So I say, okay, I'm gonna send a payload. The payload is really just that, like ultimately, what's the action that you want to take? So I'm gonna say, okay, and these are all built into the tool. I'm gonna say I want a reverse shell. Maybe I should explain that. Are people familiar with the concept of a reverse shell? No? Okay, so this is kind of interesting. When we presented this to our IT team, I don't know, 2 years ago, or something like this, 2 years ago, kind of similar thing. Oftentimes I get this. I get man, we're totally secure because we only allow someone to connect to us on port 80 and port 443, right? It's all we allow. So there's no way that you can connect with SSH, or you don't have port 22 open, right? There's no way you can connect via some other service. And what people don't realize is you're protected maybe on the way in, right? But you're not protected necessarily on the way out. If your machine is allowed to touch anything on the internet, then you can set up what's called a reverse shell. You basically tell that machine, hey, reach out to some compromised service anyway, right? Something that I set up. And what you do is you basically take advantage of that guy reaching out, boom, hold on to that, and you negotiate a connection. And it's as simple as that. So, let's see. Probably put the wrong, let's see, showcase 2.3.1.2. Give me 1 second here. You know, it's funny, I was talking to my team, and I said, should I try to do any of this stuff live? And they go, nah, because I hate waiting. Whenever I go to these things, I hate waiting for people to fix their errors. And I go, whatever, dude. So, that's it. That's all I did. And you're thinking, well, what happened? I'm connected to this other machine. I'm on that machine. I can execute under, right? I'm logged in as Cristian P on that other machine. I'm no longer on this Kali Linux box. In fact, I can show a uname. I'm on an Ubuntu machine. Whereas initially, when I was doing all this stuff, I was on a Kali machine. I'm not authenticated to any service or anything. I just sent the, yeah, go ahead.
But aren't you running that shell as the web server user?
Good point, yeah, exactly. So now what's limiting me right now is I'm running as this web user. I'll tell you one thing though, you give me enough time, you give anybody enough time, right? Like, you'll escalate, privilege escalation. So, in any event, kind of my main point there is just to show you that as soon as you get hit by these guys, you're gonna be stuck there for quite a bit if you don't have something else to protect you, right? To your point, there tends to be a kind of a kill chain. It's like, okay, this leads to that, leads to that, leads to that. So hopefully you have a lot of those layers. You often hear like layers of protection, and hopefully your code is, you know, is not too vulnerable. That you're not kind of contributing to that. In this case, it kind of just stinks because jump forward, wait ahead. It kind of stinks because it's just, hey, I'm using a library, and it's, you know, not necessarily my fault.
Just stop and start sharing again.
Oh, did it?
That's
okay.
When we brought up the Ubuntu stuff, it went wonkers.
It's a no. Let me start from here. Share screen, desktop 2. Cool.
Got it.
Is that better, Paul?
Yep.
All right, cool. So, what do you do to try to protect yourself from this? It's kind of interesting because there's years and years and years of well-established best practices. You can look to Microsoft, and you know, years and years ago. Not speaking of which, I'm sure you know they catch a lot of flack for Windows stuff that comes up in terms of security issues. But the reality is they've been dealing with this quite a bit longer, or as long as a, you know, the oldest company out there, I'm sure, with regards to like very sophisticated attacks. Because when your main you know, operating system is Windows, it's out there in the wild, and it's going to be targeted much more so than anybody else. Hopefully you pick up a few ideas to protect yourself along the way. There's a software assurance maturity model. I bring this up a million times, even internally. I personally kind of use this as my Bible, just to model an application security program. There's certs, there are a crazy number of resources. BSIN, I think Synopsys, it was a different company that started this whole BSIM approach, but it just kind of measures you against other orgs in your industry. SANS has great resources, NIST, OWASP. But the question that kind of I always get is, hey man, well it's super hard, like what do we do, right? Even with all those resources, there's a million of those. In fact, if you go down, kind of checking time here, if you go down the Microsoft best practices, it's not like 6, 7 things you have to worry about. You know, they give you quite a few ways to integrate into your entire development lifecycle. In fact, that's what it is. It's the secure systems development lifecycle. You know, it's so difficult because applications, especially nowadays, are very complex. Many authors. You have uneven footing. And when we say uneven footing, it's not just the fact that like the hacker has to be right. That's used all the time. The hacker only has to be right once. Think about like the people that we're trying to protect ourselves against, or our organizations, our systems, whatever you're working with. They're making money, potentially, and a lot of money. Maybe hundreds of thousands, maybe millions of dollars. The Swift banking scenario that I was talking about from a few years back, that was millions of dollars. In fact, what tripped up, how should I phrase this? When someone finally identified it, it was because they had messed up on the transaction attempt, and I think added an extra 0 or something of the sort.
Typo.
It was just a typo. Okay, it was just a typo that kind of tripped someone up. But we're talking about transactions that were hundreds of millions of dollars on the last couple of attempts, which is crazy if that was successful, right? So that's really the uneven footing. If you're an organization and you say, oh, this is what we tell the board, right? You're an organization, it's like you're going to give us, I don't know, $1 million for next year. Like, hey, well, we're competing against people who are making 10 million, trying to attack us, right? Usability concerns, of course. I know UX people here from our teams, but we're at odds with what they're hoping for, what their goals are, quite a bit, unfortunately. Sometimes we try to find a nice balance and compromise, but let's be honest. Sometimes the more secure it is, the more of a pain in the butt it is to use, right? And it's never ending. The last thing I'll say, it never, ever, ever ends. I had one of our guys in Halifax was out here, and we were dealing with an issue, and he says, "Why do you do this, man? It's like every day you're having to take a look at something or check. Okay, are we vulnerable to this, and so on." Like, I enjoy it, but I know definitely it's not kind of maybe a personality quirk. I don't know.
Could you drill down a little bit more on the usability concerns? You're talking about multi-factor authentication.
I mean, anything. For example, user registration. We had a discussion regarding user registration, and we send a password. And of course, from a UX standpoint, like they want it as easy as possible. Hey, confirmation. Let's take away all confirmation. I just want the person to start using our system, right? User ID, go ahead. Hell, maybe even not even a user ID. Don't authenticate. Just use our system, right? Being facetious, but no, usability concerns abound. Yeah. Two-factor for sure. That comes up here. You know, hey, two-factor introduces some friction for the user, right? Friction, which is good for security, bad for user experience. Any other questions? I'm kind of going through these. I'm trying to get through kind of a lot of the higher level stuff before we jump right into the Java stuff. So, all right, cool. So I already mentioned that there's tons of activities that you can kind of do as best practices, but I like to focus on these three because I really think this is where you make the most impact for any program. You know, if you go look at OpenSAM or you look at the Microsoft SDL or any of those other things I mentioned, you know, a list of 70 best practices, I like to just say these three things. If you're doing these three things, you're probably way ahead of the curve. One is just education and training. Even things that you don't necessarily apply immediately, go out, search YouTube, search podcasts, right? YouTube is probably one of the best sources, but there are free video sources as well, like Cybrary, and to a certain extent, things like Udemy and whatnot. Education and training, anything you can do. Go back to your organization, tell them, hey, it would be great for our software development teams to do some sort of training. There are options out there that are not expensive. And on the education and training side of things, you know, we're here for the Java users group. There's a monthly meeting for OWASP, and I know a few people who attend here and there. So I recommend it. I mean, there's a lot of resources at your disposal. The second thing I'd say is development hygiene. When I put on presentations that talk more about like how do you build an app, set program, and the first thing I say is like if you don't have development, if you don't have a concept of standards or any sort of like just what I call development hygiene, right? Like brushing your teeth every day. If you don't have a team that says, hey, these are our coding conventions, or this is what we look for, these are the design patterns. I mean, at that level, we're not even talking security. You're already in a really bad spot. Like again, these are not mutually exclusive concerns, security and just having good development practices ultimately, right? And I'm talking about the bread and butter sort of stuff. Small, focused check-ins, commits, you know, what have you, pull requests. Regular code review, and a healthy unit testing. That's what I mean when I say hygiene. Again, I'm not even calling out like security-specific stuff. And then the automation side, automate everything that you possibly can that you know needs to be, whether it's tested, whether it's integration to some tooling so that you do for analysis. So, and you know, Paul Weber is our kind of DevOps guy and guru here, and so he's constantly, you know, kind of, how should I phrase this? Carrying the flag of like automation, right? We want full CI/CD, and it's true. I'm a firm believer that the kind of the CI/CD path is how you get the good security practices built into your system, because it's from the beginning to delivery and actually beyond, right? And if you integrate security into each one of those pieces, you're way ahead of. I mean, like way ahead of the pack, way beyond just thinking about things here and there. Let's see. I'm going to try to cover all this stuff in the next 15 minutes, and then we'll take the break and go into the Java, like a bit more Java specific stuff. Related to just activities, right? Things I recommend looking up if you're education. Well, what do I look for? What sort of training? Focus on threat modeling activities. That's where you're going to get the most bang for your buck to understand how to protect the code and systems that you design. These are kind of the 4 things I just very, at a high level, expect to come out of this general activity. Start with some sort of context diagram of your system. Document what type of data is flowing between different parts of your system. And you decide, decide what level you want to do it at. I say context diagram because when we're talking data flows, it's kind of the highest level. It's like, system A, system B, this flows. User, is tied in there. If you want to go 2, 3, 4 layers deeper into the whole data flow, be my guest. But the whole point is to itemize your potential threats, or kind of identify vulnerabilities and consider mitigations. And I know that sounds very, again, very hazy, very nebulous. But we'll kind of walk through that. So assume I have just some hypothetical system. This is my context diagram for it. Some user interacts with the reservation system, and that reservation system interacts, or barely interacts, sends things off to some reservation queue, so on and so forth, right? This is a level that you can start at, and you're still, in a pretty good spot. But for each one of these flows, what you should do then is document what type of data flies through there, what is exchanged, right, between the 2 systems, or user and system, and so on. Do we need to ask yourself, do we need to protect it? Like, this notification service, do I care if this other subsystem, this processor, authenticates against it, or is this some internal separate service that I use and everything on our network is allowed to the same thing? Maybe that's the case. Depends on your design, right? But you should ask yourselves those questions, and you don't do it open-ended either. Like I think early on, a lot of people, they'll start here and then they kind of brainstorm with their team. Maybe the architect sits down with some leads and they go, okay guys, how can a hacker break this? And that's not the way you should do it. It should be very methodical. There are frameworks out there. Probably the most popular one, the one I push here, going back to the Microsoft approach, is Stride. It's a little bit long in the tooth, but start with something. And start with something that's methodical and repeatable. So Stride is just an acronym, and it's like, do we have spoofing concerns, spoofing of identity, right? Do we have tampering of data concerns, repudiation concerns? It just walks you through. And you literally just ask yourself that question for each one of these flows. You say, okay, between the notification service and the user, so we're sending something back, do we care about the spoofing of identity? I don't know. In other words, does the user, sending something back to the user, do we have to authenticate that in any way? Right? You kind of just ask yourself these questions every single interaction. And you'll be surprised, it tends to uncover pretty interesting stuff. I can't talk about a specific project, but let's just say, hypothetically, we're looking at smart batteries in some of our devices. The question came up there. It's like, oh yeah, there's data flow between the smart battery, right? It's a smart battery. There's information that flies between the 2. And so I go, okay, hold on, well, let's walk through this exercise. And yeah, sure enough, we're thinking, oh man, maybe we should authenticate the battery, because we actually are going to rely on the data that's coming from a battery. Okay, and whoa, my God, what if the battery data is tampered with? Oh, well, we make decisions downstream based on that. It's that sort of stuff that starts being revealed if you kind of just approach this methodically. Any questions on that? Yes?
Basic input validation and data coming from the battery.
Yeah, exactly. Basic input validation on the data coming from the battery. It's like I expected it to be in some format. Whoa, what the hell, right? It's not in that format. Or it goes, the threshold, the range, or I should say the value that's sent to me is outside some threshold, some range that I was expecting. Yeah, and Hank knows quite a bit about that because he's dealing with some pretty cool systems here where we have to do tons of validation. Yeah, so kind of starting to get to a bit more Java-specific stuff, and then we'll get into kind of code samples and whatnot. But can I get more specific? Well, yeah. Look, Java-specific stuff. Java's been around for quite a while at this point. There are older guides. There's updated guides. I think using even Java 9, using features that are in there. Secure coding guidelines for SE. I mean, you can look through them. They're kind of broken out into here are general practices, here are denial of service concerns, so on and so forth. Go and look at oracle.com, that works. so on. Security features in Java, so there's pretty good documentation just around the high-level features. We're not going to cover nearly all of them. There are things in there that, you know, even I haven't used in quite a few systems that I've built. And then there are some that maybe you use, like the key store APIs, right? I've used those extensively at an org I was at, but then interestingly enough, they're pretty feature-rich. You'd be surprised. I was talking before we started here with a few people. Said, look, out of the box, out of the JDK itself, you get quite a bit of you know, functionality on the security side without having to go and download 20 libraries to do 2 things. So yeah, I definitely recommend taking a look at those things. Well, let me pick apart. I find it a little funny because a lot of these guys are along the lines that you see here, but nonetheless, it's relevant. These are actual, you know, kind of Java secure coding guidelines. They go in a lot more detail. Again, kind of poking fun at it a little bit. But basically, some of these, you know, result in what I was saying earlier: write good code, right? Prefer to have obviously no flaws rather than no obvious flaws. To sit down and think about that one for a little bit. What they're kind of mentioning there is basically don't get too clever. Like if you can't look at the code, figure out what it's doing, and make a determination one way or another, it's complex, right? It's hard to maintain, so potentially bug-ridden. It sounds crazy, but I tell people when I'm mentoring, or when I used to mentor new you know, software engineers, I'd say, if you sit down and you go, oh man, that's pretty clever. Like, hold on a second. Like, think about, is that really what you want to put in there? Because someone has to maintain this long term. And yeah, you can comment it, I suppose, but we all know, you come back to it 1 month later, it's like, crap, okay, wait, how did that work? How did that work? Hold on. So it's, you know, kind of error prone. Avoid duplication, another very common thing. Again, going back to the hygiene, and these are in the official Java best practices. If you find yourself copying and pasting code, period, it doesn't matter if it's external code, it doesn't matter if it's your own code. Like, oh man, I used this same construct somewhere else. Huge red flag, right? It's a huge red flag. Just from a, again, maintainability aspect, but also from a you know, potential to introduce bugs. So establish trust boundaries. We're kind of talking about that. Encapsulate. Again, we're saying use good hygiene or use good development practices in general. We're not even really diving deep there into, hey, this is a security-specific concern. So, time to hop into a couple of very high-level things before we get into Java-specific stuff. So, injection. I'm not going to beat a dead horse on injection. I mean, this is the hello world of secure coding. If you look up anything, it's going to kind of give you an example like this, right? This is classic injection. We say, oh man, SQL injection, hell man, you know, we get some user input, we're constructing some SQL statement, some SQL statement, and we directly insert it into that statement. We're concatenating the strings, boom, we feed that into you know, the statement, call it bad, and all goes to hell. And it's funny because even though this is the hello world example, I see this still all the time. And I get things like, oh man, we're not vulnerable to SQL injection because we use stored procedures. I hear that too. It's like, that's probably better. You're in a better spot because at least you're passing. If you're not familiar with stored procedures, it doesn't matter. The main point is like, you can still, in the stored procedure itself, that's code too, you can still pass forward bad data to that. You're just executing at the database level as opposed to in the application. Again, this is kind of the classic example, but here's the funny thing. The reason I think that this is so pervasive goes back to the copying and pasting sort of thing. You go to the default tutorial, even today, even the most up-to-date one, this is kind of the approach they're going to show you to use initially. It really is. Like, it's like, hey, this is how you use the connection API. It's fine. We'll talk about that stuff later as well. I'm not, just in the essence of time, we're not going to go through better SQL. Again, hello world. Use prepared statements. Pretty straightforward. You basically parameterize this rather than actually directly popping it in there. you parameterize a statement, and then a prepared statement, you can substitute the value. All the kind of escaping that's necessary happens here. What I did want to show though is injection. SQL is kind of the hello world example, but injection happens everywhere, like in all sorts of places. Whether you're working with some logging API, whether you're working with command, runtime, and you want to get the process going in Java. It's like same sort of problem here. Realize this, right? I mean, if anyone's familiar with how bad this is, it's like file I don't care about, right? But then I say, okay, well, let me close off that statement and let me put in some other statements in here. Let me do a curl to that bad address that we had earlier. Well, that's obviously not an address, but you get the gist. That bad address that I had earlier. These injection concerns abound everywhere. Basically, anywhere that you are going to eventually parse the input for the user and going to, in a sense, like interpret it somehow, right? You have a potential injection concern there. The prime faces issue, expression language, injection concern. Basically, what it boils down to. So, questions there at all? Yes?
How would you address the bad logging?
Oh yeah, that's a good one. Dan, how would you address the bad logging? There's a OWASP library that you can use. You can grab the OWASP library that basically ties into the logging framework that you're using. Configure it so that kind of actually, it doesn't even sanitize it. What it does is it encodes the values. So I think in your case, you decided, hey, I'm going to encode everything as HTML. So it'll do the necessary escaping and so on.
So are we talking about whitelisting?
No, in this case, we're just talking about encoding it. Okay. Encoding the data, yeah. So, if I'm going to log it, let me encode it into a format that I know is going to be pretty safe. You can, if you wanted to, you can whitelist, tie in a few convenient functions that you use sprinkled throughout here and there. Probably not the best from a design standpoint because you have to use it everywhere. Tying into the logging framework itself for that case is probably going to be the best. So that's one thing. You're protecting against spoof logging, right? Like someone might say, hey, I'm trying to cover my tracks, so I'm going to insert new lines and put fake entries in there that make it look like I logged out. So later on, when maybe someone's doing forensics. But there are other things you got to worry about because some of these sophisticated logging frameworks that we all use have pretty cool appenders. It could be email appenders, JDBC appenders, right? That data might go to all sorts of places. And it depends on if you're using those, right? You kind of have to make that determination yourself during design. Yes, in most cases, you're probably just logging a file somewhere. So you're concerned with kind of log tampering, log spoofing.
The example you showed on JDBC, oftentimes people use frameworks like Hibernate or iDias or things of that nature.
Yeah.
So what you're saying is it's really up to us to make sure that you audit those kinds of frameworks and make sure that
That's a good. I'll get to that a little later. Cool. Yeah. I was going to kind of walk through, the exercise of like, hey, where would I fix this? But we already touched on that. Ultimately, I was going to say, well, it depends on what you're trying to fit, what you're trying to protect against. If it's logging, yeah. If it's logging, we do it there, so on and so forth. But that's about it. I'll leave it at that. We'll take a break. Sound good? And then we'll dive into some other stuff.